I really like to take this opportunity to welcome everyone, because this is a very special event this evening. It's all about prize-winning engineering achievements and the people who brought them to the world. It is an annual highlight for the Academy, and for me in particular, to have this opportunity to recognize such contributions and contributors with this very special ceremony. And this is the most precious space in the entire National Academy's complex, this particular Great Hall. So to have it here. We are here to present the 2015 National Academy of Engineering Awards, the Charles Stark Draper Prize for Engineering, and the Fritz J. and Dolores H. Russ Prize. Our distinguished honorees for the Draper Prize are Dr. Nick Holonyak, Dr. M. George Crawford, Professor Russell D. Dupuy, Dr. Isamu Akasaki, and Dr. Suji Nakamura. And our Russ Prize honorees are Professor Graham Clark, Professor Erwin Hockmeyer, Dr. Ingapur Jeg Hockmeyer das Sawyer, Dr. Michael Merzinik, and Professor Blake S. Wilson. You'll hear more about them later during our presentation ceremony, but for now, please enjoy the dinner, and in 1 hour, we'll come back for the presentation of the awards. So please enjoy yourself and all your table mates here this evening. Thank you very much. Well, good evening again. Good evening again. And, you know, I really hope that you have enjoyed your dinner and the camaraderie around your table. From the noise in the room, the prospects are very good for that outcome, I must say. I very much appreciate lots of noise at parties like this. I'm most pleased to take this opportunity to recognize a few of our special guests and supporters. And allow me to do that right now. Representing the Charles Stark Draper Laboratory are Dr. Ken Gabriel, President and CEO of the Charles Stark Draper Laboratory. Ken, you're there somewhere? Good, good. And also Franklin C. Miller, Chairman of the Board of Directors of the Draper Lab. Thank you. And as we say, Dr. Draper's daughter, Martha Draper Dittmeyer, and her husband, Steve Dittmeyer, are here. And for the Russ Prize, we have Mildred Midge Crum, who is Fritz Russ's sister. She's here. Mildred? And representing Ohio University, we have Dr. Roderick McDavis, President of Ohio University. Rod? Dr. Dennis Irwin, Dean of the Russ College of Engineering and Technology at Ohio University. And Dr. Akira Sugita, he's the Science Counselor of the Embassy of Japan. Very close friend. I told Akira we were going to give him an office in this building here so often. Dr. Ralph Cicerone, President of the National Academy of Sciences, and his wife, Dr. Carol Cicerone. Ralph? Carol? And representing the 2015 Engineers Week, we have Darren J. Drollinger. Darren? He is the Director of the American Society of Agricultural and Biological Engineers. And we have previous recipients of the Draper and Russ Prizes. We have members of the Draper and Russ Prize selection committees and the National Academy of Engineering Council. We have many family members, friends, colleagues of this year's Draper and Russ Prize recipients. We're really very, very happy to have all you here with us this evening. The National Academy of Engineering Council Chair, Mr. Charles O. Holliday, Jr., is unable to be here this evening, and he really sends his regrets and best wishes for this very memorable event. Now we move directly into the presentation of the Charles Stark Draper Prize for Engineering, which recognizes the world's most significant engineering innovations and honors the engineers who created them. The Draper Prize is recognized globally as the most prestigious award for engineering achievement. This year marks the 26th year since the first prize was awarded. We really commend the Draper Laboratory yet again for its generosity and ongoing commitment to recognizing top engineering achievements in the spirit of Doc Draper by working with the National Academy of Engineering. To date, 47 engineers have received this honor, and tonight we will add 5 more to this distinguished list. Let me just say a little bit about the namesake behind the prize, Dr. Charles Stark Draper. He was born in Windsor, Missouri on October the 2nd, 1901. In 1922, he graduated from Stanford University with a Bachelor of Arts degrees in psychology and entered MIT, where he earned a science bachelor's degree in electrochemical engineering and subsequently a Doctor of Science degree in physics. Doc Draper, as he was known, became the father of inertial navigation, which allows vehicles to sense changes in direction by linking gyroscopes with accelerometers along 3 axes. He evolved the theory, invented and developed the technology, and led the effort that brought inertial navigation to operational use in government and commercial aircraft, space vehicles, and submarines. He was a professor of aeronautics and astronautics at MIT, where he founded the instrumentation laboratory in the 1930s. In 1973, the lab incorporated as a separate nonprofit research and development laboratory bearing his name. The Charles Stark Draper Laboratory has carried forward its founder's dedication to applied research, engineering development, education, and technology transfer. While deepening its expertise in guidance, navigation, and control over the years through work with the Department of Defense and the National Aeronautics and Space Administration and commercial customers, Draper Lab's expertise today is also being applied to solve critical technology problems in biomedical engineering, energy, and in other fields. Now, please join me in welcoming to the stage the President and Chief Executive Officer of the Charles Stark Draper Laboratory, Dr. Ken Gabriel. He will assist me in the prize presentations. Ken? That is tuned up. Excellent. Okay, the recipients of the Draper Prize share a $500,000 prize, and each receives a commemorative medallion and certificate. The 2015 Charles Stark Draper Prize for Engineering recipients are Dr. Nick Holonyak, Dr. M. George Crawford, Professor Russell D. Dupuy, Dr. Isamu Akazaki, and Dr. Suji Nakamura. Their citation reads, "For the invention, development, and commercialization of materials and processes for light-emitting diodes." LEDs are used by billions of people on a daily basis in computer monitors, cell phone screens, televisions, traffic lights, home lighting, digital watch displays, medical applications, and many, many more. LEDs produce the greatest amount of light for the energy used and have the longest lifetime of any lighting sources available. The $33 billion LED industry has stimulated global growth, job growth, and dramatically lowered the cost of energy for lighting. In 2012 alone, more than 49 million light-emitting diodes were installed in the United States, with an estimated annual savings in energy costs of $675 million. In 2013, light-emitting diodes in general lighting applications reduced carbon dioxide emissions by the U.S. by more than 12 million tons. So now is my pleasure to ask the winners of the Charles Stark Draper Prize for Engineering to come on stage as your name is called to receive your award and remain until all winners have received their awards. So I will call your names and you will come forward, and then subsequently you will be seated here until all winners have received their awards. Now, Dr. Nick Holonyak could not be with us this evening, and accepting the award in his absence is Dr. Phyllis M. Wise, Chancellor of the University of Illinois at Urbana-Champaign. Phyllis. Do you want the picture on this side or on that side?
Oh, here, stand.
No, okay, Phyllis. Here's your prize, so I'm supposed to. Isn't she getting a picture? Now we got it. Yep. Dr. M. George Crawford, Philips Solid Lighting Fellow at Philips Lumileds Lighting. George, please come forward.
Okay.
Professor Russell D. Dupuy, Professor and Steve M. Chaddock Endowed Chair of Electro-Optics at the School of Electrical and Computer Engineering at Georgia Tech. Russell, welcome. Dr. Isamu Akasaki. Dr. Akasaki could not be with us this evening. Accepting the award in his absence is Dr. Tetsuya Takeuchi, who is Associate Professor of Department of Material Science and Engineering at Maijo University. And last but not least, we have Dr. Suji Nakamura, Professor, Department of Materials at University of California, Santa Barbara. Dr. Nakamura.
That's it? Okay.
Let's see, do we have a group photo at this point, do we not? That's what it says here.
We can wait for afterwards.
So when do you want it?
We can do it after.
Want it afterwards, all right? Now, we now have George Crawford is going to come forward and he's going to present some remarks on behalf of the winners. And then we'll have a group photo subsequently. George?
Thank you, Dr. Moat. And hello, everybody. First, I just want to say it's a great privilege for me to represent my colleagues here at the podium tonight. We thank the NAE and Draper Labs and everyone associated with this prize. It's a tremendous honor for us to receive it. Thank you very much. We also want to thank our wives and families. Our wives have had to put up with us for decades chasing photons of various colors, and we thank them very much. Finally, we want to thank our co-workers. Much of this work is done in teams. Most of this work is done in teams, and without our co-workers, the work would not have happened. I'm sorry Professor Akasaki and Holonyak cannot be here tonight. Professor Dupuy and I were both students of Holonyak at the University of Illinois, and he in turn earlier was a student of the great John Bardeen, also at the University of Illinois. The demonstration by Nick Holonyak in 1962 that compound semiconductor alloys could be used to fabricate red LEDs and lasers drove the solid-state lighting revolution. It demonstrated that high-efficiency LEDs could be made, and all of the high-efficiency LEDs today are made using compound semiconductor alloys. Holonyak predicted at the time that his results would lead to solid-state lighting. He also said that much more experimental work needed to be done. Well, the experimental work so far has lasted 50 years, and it's still going. It's taken many forms. New alloys have been investigated to develop new colors. Very increasingly complex semiconductor structures have been grown to improve performance. Thin layers, quantum well structures on a nanoscale were grown long before the term nanotechnology became a popular buzzword and used for LEDs. My contribution in this was working with others, developing and pioneering yellow LEDs and improving the efficiency of red LEDs. Professor Dupuy developed MOCVD growth technology, which is used to produce all types of LEDs. Professors Akasaki and Nakamura developed blue LEDs. And blue LEDs, when combined with a down converter phosphor, give white, which give solid-state lighting. Professor Nakamura also developed a blue laser, which is being used now for high-intensity lighting in headlights. The early LEDs were barely visible in a lighted room. Today's LEDs are more than 1,000 times brighter than the early LEDs. The Super Bowl this year was illuminated with LED floodlights. LEDs are replacing all forms of lighting, all forms of conventional lighting in general illumination. And in third world areas where there's no electrical grid, LEDs combined with solar cells are lengthening the day and bringing light to people that only had fire and kerosene stoves before. The conventional lighting technology has lasted a little over 100 years. It's expected that LED lighting technology will last much, much longer. In a September 2000 Journal of American Physics article, Nick Holonyak argued that LEDs are the ultimate lamp. There's no end in sight for solid-state lighting. I want to thank you again for honoring us, for our contribution to this worldwide ongoing effort in developing LED technology. Thank you very much.
Very nice, huh? Really very nice remarks.
Thank you.
Perfect.
Now we're going to have a group.
Well, thank you very much, George, Russell, Suji. We're really honored to have you all join us for this esteemed Draper Prize celebration, and thanks also to Phyllis and Tetsuo for accepting the awards on behalf of your colleagues. It really helps round out the evening for all of us. So please join me in one last round of applause for these Draper Prize winners. Now it is our opportunity to present the 2015 Fritz J. and Dolores H. Russ Prize. First of all, let's sit back and enjoy a short video about the Russ Prize and this year's winners.
The Russ Prize is the premier prize in bioengineering. It was originally awarded in the year 2001 and is awarded every other year. It's awarded by the National Academy of Engineering in cooperation with Ohio University. Fritz was one of the original entrepreneurs after World War II in the electronics industry. He and his wife Dolores formed their company in the early 1950s. They dug the foundation for their original building themselves. When they sold the company in 1987, it was one of the largest engineering consulting firms in the country. They lived modestly, even though they were very wealthy people at the end of their lives. They started the award because Fritz was always concerned that the Nobel Prize was not awarded in engineering, he conceived the Russ Prize to fill that gap. The type of person that would win the Russ Prize is someone who would take a basic scientific concept, apply engineering principles, and solve a practical problem. That practical problem, in the case of the Russ Prize, would have significant impact, be in widespread use, and improve the human condition. Fritz was known for thinking 20 or 30 years into the future. In fact, I would say that his impact on Ohio University itself is to inspire us and to set the example for long-term visionary thinking. Examples of past winners of the Russ Prize have included the inventors of the implantable heart pacemaker, the inventor of kidney dialysis, the inventor of the automated DNA sequencer, and the inventor of the enabling technology for heart-lung machines. The Russes wanted to ensure in perpetuity that achievements such as these continued to be awarded, and thereby inspiring a new generation of engineers.
The 2015 Fritz J. and Dolores H. Russ Prize is awarded to Blake Wilson, Graham Clark, Erwin Hochmeyer, Ingeborg Hochmeyer de Soya, and Michael Merzenich for engineering cochlear implants that enable the deaf to hear. Michael M. Merzenich, a neuroscientist and professor of otolaryngology at the University of California at San Francisco, established some of the neurophysiological foundations of present cochlear implant, or CI, designs in 1971. Best known for his groundbreaking discoveries in multi-site stimulation of CIs and neuroplasticity, he, along with other CI contributors, developed the Advanced Bionics Cochlear Prostheses, which enabled greater access to and commercialization of CIs. Electrical engineers Erwin Hochmeyer and Ingeborg J. Hochmeyer de Soya began their work on CIs as a team in the mid-1970s in Austria. Building on existing knowledge of the physiology of the auditory system, their engineering-based approach led to the world's first microelectronic multi-channel CI, which is considered to be the prototype of today's modern CIs. The first two devices were implanted in 1977 and 1978. The Hochmeyers have continued to develop cutting-edge hearing implant technologies through their company, Med-L. Meanwhile, in the 1970s in Australia, professor and physician Graham Clark was independently studying multi-site stimulation of the cochlea by routing particular speech sounds to its various parts. He was focused on designing an implant that would sit flawlessly against the cochlea to correctly stimulate nerve endings. Clark's design was perfected in 1978, and not long after, he implanted his CI into a patient. Clark went on to help create Cochlear Limited, which has provided implants to more than 250,000 patients over the last 30 years. Blake S. Wilson, a professor at Duke University in Durham, North Carolina, began working full-time on CIs in the 1980s when he developed the continuous interleave sampling system. This method made it possible for CI recipients to understand words and sentences with far greater clarity than before. Wilson's breakthrough laid the groundwork for sound processing strategies used widely in today's CIs and resulted in a rapid expansion in the number of deaf and nearly deaf persons who have received a cochlear implant in one or both ears. More than 320,000 hearing impaired people have received CIs in one or both ears. This life-improving device was made possible through the groundbreaking work of Blake S. Wilson, Graham M. Clark, Erwin Hochmeyer, Ingeborg J. Hochmeyer de Soya, and Michael M. Merzenich. And for this, we award these pioneers the 2015 Fritz J. and Dolores H. Russ Prize.
Wow, very nice. Very nice indeed. Ladies and gentlemen, please join me in welcoming to the stage Dr. Roderick J. McDavis, the president of Ohio University, who will assist me in this awarding ceremony. Rod? The Rust Prize, as you heard, recognizes a bioengineering achievement in widespread use that improves the human condition. The recipients of the Rust Prize share a $500,000 award, a commemorative medallion, and a certificate. In addition, the recipients are invited to present a formal lecture hosted by Ohio University in Athens, Ohio. The 2015 Fritz J. and Dolores H. Rust Prize honorees, as you've heard a couple of times now, are Professor Graham Clark, Professor Erwin Hochmeyer, Dr. Ingeborg J. Dessur, Dr. Dr. Michael M. Mercinick, and Professor Blake S. Wilson. Their citation reads, "For engineering cochlear implants that enable the deaf to hear." Cochlear implants are small electrode devices that provide people with severe to profound sensorineural hearing loss with a sense of sound. The quality of that sound differs from natural hearing sound, with less sound information received and processed by the brain, but many hearing impaired people are able to hear and understand speech and environmental sounds. Newer devices and processing strategies allow hearing impaired to hear better in noisy settings, enjoy music, and even swim with their implants. More than 320,000 hearing impaired people around the world have received cochlear implants and is the most used neural prosthesis developed to date. Now I ask the winners of the Rust Prize to come forward as your name is called to receive your award, as we did earlier for the Draper Prize. And so the first awardee would be Professor Graham Clark from the University of Melbourne, who cannot be with us this evening. He sends his sincere regrets and his congratulations to his colleagues and his determination to visit Ohio University also. Dr. Ingeborg J. Hochmeyer de Sawyer, she is Chief Executive Officer and Chief Technology Officer of MED-EL. She's also the first woman Rust Prize recipient, and also the first woman ever to get a doctorate degree in electrical engineering in Austria as well. So she has many firsts. Ingeborg, please come forward. Your prize.
Okay, so the script is here.
Dr. Erwin Hochmeyer, co-founder of MED-EL. Erwin? Dr. Michael Merzinek, Chief Scientific Officer and Chairman of Posset Sciences Corporation. And Professor Blake S. Wilson of Duke University. So now we are have the opportunity to have Ingeborg Hochmeyer is going to say a few words on behalf of all the winners of the cochlear implant. Ingeborg? You got your notes? Good. Okay, good.
Yeah, Mr. President, dear members of the generous Russ family, ladies and gentlemen, the Fritz and Dolores Russ Prize recognizes a bioengineering achievement in widespread use that improves the human condition. This achievement should create for good at the highest level, helping the public better understand and appreciate the contributions of engineers to our health, well-being, and quality of life. In the name of the 5 recipients, Mike Merzenich, Graham Clark, Blake Wilson, Erwin Hochmeyer, and myself, who received this prize for engineering cochlear implants that enable the deaf to hear, and in the name of many others who contributed to the development of the cochlear implant, and some of them are in the room today, up to the status that it has now, I would like to thank the committee, Ohio University, and the NAE for selecting the cochlear implant for this year's Russ Prize. All 5 of us have worked in the field of cochlear implants for decades and are very passionate about the field. And the CI is indeed a very special development. It is the first replacement of a human sense, the sense of hearing. The aims of the Russes are fulfilled with this device in a very visible way. Users of cochlear implants typically wear their audio processors all waking hours in order to hear and understand and enjoy sound. The cochlear implant has to do with communication, with being able to take part in society. It is connected with every child's human right for education, and there is a growing body of evidence saying that it can alleviate isolation and cognitive decline in older adults. All of this year's Russ Prize recipients from different parts of the world have in common that they developed university-built prototypes of cochlear implants and improvements of their features with pioneer patients, which after many years of engineering and research ultimately resulted in today's widely spread cochlear implants provided by the three biggest cochlear implant manufacturers, one each in Australia, in Europe, and in the US. In the year 2014, approximately 55,000 cochlear implants have been implanted around the globe. This is a big number, but still much smaller than the cardiac pacemaker, which was recognized with the first of the RUS prizes in 2001, and where the annual numbers far exceed 1 million per year. While in most highly developed health systems, almost all children born deaf or with a considerable hearing loss do in fact receive a cochlear implant before the age of 5, at around which the period of plasticity ends. This is not the case around the world yet, and there is also a huge unmet need with every age group in acquired deafness, especially in older adults. Deafness is very common. Almost every family is affected, probably also in this room. Since this piece of engineering, the cochlear implant, is available, I would like to urge everyone who does not hear to his or her satisfaction to do something about it. Try a hearing aid, get it fitted and refitted, and if it is not sufficient, try hard to get an implant, a cochlear implant. Poor hearing is too big a barrier to communication and quality of life to accept it easily. Thank you very much again.
Very nicely done. Very nice. Now we have a group picture.
Okay.
Well, I really, truly hope that you enjoyed this evening as much as I have. Little is better than honoring great engineering achievements and those individuals really who made it happen. I thank everyone who participated in this whole event and all our guests who joined in this celebration for this 2015 National Academy of Engineering Awards. Please join me one last time for recognizing all the award winners that contributed to this program, because it's really, really something.